All right, good morning, ladies and gentlemen. Today is a half day. Our goal today is that students will be able to identify the degree of rotational symmetry and the number of lines of reflectional symmetry of polygons. It's a lot of fun. All right, but first we have a pump up. So please take a few minutes, think about this, and then the answers will appear. You want to test yourself. All right, if you've been focused, that should have been enough time to get some ideas down for those three problems. Tonight's homework is page 58 and 59. All right, let's check our answers. This coordinate notation is telling us that each point will be rotated 180 degrees. If you reflect that point to -5 across the x-axis, you'll get the ordered pair 2, 5. And if you reflect this point across the line y equals 3, you will get that point. Some strategies, you may want to actually plot that. Think about, you could write an equation, write a notation, but I think just plotting it is sufficient. All right, so you guys have this. You want to find this in your packets. I'm going to give you a few minutes to take your best guess without your phones. We're not Googling any of this. All right, you're going to identify the degree of rotational symmetry and the number of lines of reflectional symmetry of polygons. But first, we're just going to look at symmetry of polygons. A polygon is named according to the number of its sides. So if you see if you can name them all. So take a minute. A three-sided polygon is called a... Yep, you got it. Okay, write it down. Take a minute, put as many as you can. Actually, I will put a timer up here. Let's say 2 minutes. Do as many as you can. All right, maybe that was too much time. I'm taking away 30 seconds. Okay, let's check our answers. Ready? Drum roll, please. All right, let's check them. There actually are a couple different names that you could use for an 11 gon. You can Google those. There's also Um, there's all sorts of wonderful names. But an n-gon. What is a polygon? Like, what does poly mean? It means many. A many-sided figure. Polygon. All right. Let's write down some notes. Regular polygons are polygons that have congruent sides and angles. That's important. So just the word regular gives us a lot of information. The center of a regular polygon is the center of rotational symmetry and equidistant from each vertex. The central angle of a regular polygon is equal to the degree of rotational symmetry. Okay, so a central angle is identified here. If we draw line segments from a vertex to the center, on each of the vertices, that angle right there is a central angle. All right. The measure of theta, this is a Greek letter, theta. Let me write in a color you can see. Oh, in a size that will work. Theta. The measure theta, it's kind of like a zero with a little loop in the middle, of a central angle of a regular polygon with n sides is given by the following. So I want you to think about this for a minute. Here we have a pentagon, right? And we know if we were to draw a circle, we know how many degrees there is in a circle, so how much would each of these angles, what would the measure of each of those angles be? So we take 360 degrees and we divide it by what? By n. What's n? N is the number of sides. Oh, I just realized I have that over here. N is the number of sides, and 360 degrees divided by n is our theta measure. All right. Great. You all have it written down? All right, moving on. Rotational symmetry. A figure has rotational symmetry if and only if it has at least one rotation, not counting rotation image of 0 degrees or multiples of 360 degrees, which coincides with the pre-image. Okay, the number of positions in which the object looks exactly the same is called the order of the symmetry. I think we say order of symmetry, not order of the symmetry, but the order of symmetry is what we're looking at. And the measure of the central angle of a regular polygon is called the degree of symmetry. And really we're trying to figure out how many degrees is in each central angle, right? So the measure of the central angle is called the degree of symmetry. How many degrees do we need to rotate until we are symmetric again? Here, how many degrees until I align again? Okay. Great. So, in this shape, we want to figure out what is the order of symmetry. As you rotate 360 degrees, how many times does the polygon map onto itself? How many times does it match up exactly? If I take where we are rotating about the center of that triangle, and if I rotate here, this, say that's my starting vertex, 1, 2, 3. So our order of symmetry is 3. It maps onto itself 3 times. All right, you keep going. The degree of symmetry, I would take, if I, let's see, what I'm asking is if I drew a segment from the center out to a vertex, what degree measure would that be? So I would need to take 360 divided by 3, and I get 120 degrees. Okay, you keep going with this. Take a few minutes. see if what we got matches up. All right, any questions on how we find the order of symmetry or the degree of symmetry? Okay, great. So now we want to look at reflectional symmetry. A figure has reflectional symmetry if and only if its reflected image across a line coincides exactly with the pre-image. This line is called the axis of symmetry or the line of symmetry. So different ways of saying the same thing. All right, so in this little ladybug, the line of symmetry right here, everything on this side matches up exactly with everything on this side, right? This length and this length are the same length. They are congruent sides. All right, try to identify what else is congruent. So in all of these we have one line of symmetry, but here we actually have two. We could fold this down or we could fold this over and it would match up either way. All right, so here are some pieces of information that help us see, okay, those two are congruent. These two are congruent. This is the same line, right? We're going to talk about that, how it's called the reflexive property. Oh, it's just the same line. All right, cool. So, determine and sketch the number of lines of reflectional symmetry for each regular polygon. Notice the word regular. Regular, if you forgot what that means, you want to look back in your notes and remind yourself, what does it mean if it's regular? Okay, so we're supposed to sketch the reflectional symmetry. So initially I think, all right, okay, if I folded this triangle on that line, it would be symmetric. It would map onto itself, right? The one side maps onto the other side. All right, or they would coincide. Where else could I fold it? Exactly. That's what I was thinking. You could go there, or you could go there. So all three of those are our lines of reflectional symmetry. Is there anywhere else I could draw a line and fold it onto itself? Nope, that's it. So I'm going to say this has three lines of reflectional. So it says sketch, determine and sketch the number of lines. So I want to identify there are three lines of reflectional symmetry. All right, take a few minutes and try this for the other shapes. All right, hopefully that was enough time. Let's check and see. Woo! Did you get that? 3, 4, 5, 6, and 8. Okay, so the number of lines of reflectional symmetry is equal to either the number of sides the polygon has or the number of vertices the polygon has. All right, awesome. Now we get to look at some fun logos. Okay, so logo symmetry. Rotational symmetry, order of symmetry, degree of rotation, reflectional symmetry, and draw lines of reflection. So we have 1, 2, 3, 4, 5 things we're going to determine for each of these. This one's a little bit unique. I could draw a line here, there, 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 there. There isn't, well, there isn't a line that doesn't go through that center that I couldn't draw that wouldn't be a line of symmetry, right? As long as I go through that center, the center of this picture, it's going to be symmetric. So I would say what the order of rotation is infinite? It's infinite order of rotation. Alright, so does it have rotational symmetry? Yes, it does. What is the order of rotation? I would say infinite. Degree of rotation. Well, really, it could be any degree of rotation. I think when we're talking about degree, it's more like what is the central angle, and in this case, any angle will work. So that I don't think that really applies in this case. Reflectional symmetry. Does it have reflectional symmetry? Yes, it does. Here's an example of a line I could reflect over, or we could have that line, or we could have that line. So here are some examples, but how many lines are there that you could draw? An infinite number. Yes, as long as they go through that center point. Okay, you guys get the gist? The idea? Some of these won't have any, like if this has no symmetry, whether if we rotate it or if we reflect and there is no symmetry, then there is no symmetry. This doesn't have reflectional symmetry. I can't draw a line here or there or there. There is no way that I can slice this Nike symbol so that it will fold onto each other. Alright, so have some fun with those and work on your vocabulary, order of symmetry, order of rotation, degree of rotation. Alright, great, have a wonderful weekend.